Hey, what's up, everybody? Today we're going to take a look at how to calculate inflation into your returns and to figure out what an actual inflation adjusted rate would be. I'm going to start off by doing this the wrong way. I see a lot of people do this. It's kind of a hand wavy math. And maybe it's okay for like a quick approximation, but it's not mathematically correct. The wrong way that people do this is they say I have like a 10% return, and then I have 3% inflation. So what they do is they just say 10% minus 3% is equal to 7%. So I have a 7%, what they call like a real return or inflation adjusted return. This is actually incorrect mathematically because percentages don't always play really nice in mathematics, so we can't always just do addition and subtraction with them. It might be close for like a, just back of the envelope calculation, but if you really want to get the real value, we have to do something else. So before we get into actual mathematics of what we should do, I think to help you understand where the equation comes from is to think about bananas, interestingly enough. So let's imagine that you've got, some kind of economy built on bananas, or you buy a lot of bananas. I'm going to draw a really poorly drawn banana here. All right, so let's say you go to the supermarket and a banana costs $1. All right. So we want to know like what's our purchasing power in terms of bananas. All right, so let's say that you have $100. All right, if you have $100, then your purchasing power is equivalent to 100 bananas. All right. Now let's imagine that you get a 50% return, okay, on your investment. So now you have $150. Now, if we have 0% inflation, that is, I come back to the store after I've got my 50% return. Let's say this has been like maybe 1 year. We had like a pretty good year, just to make things easy. I've got a 50% return, but let's say that bananas have not gone up in price at all. They're still $1 when I go back to the store. Well, now I have the purchasing power of 150 bananas. Okay, makes sense, right? I can now buy 150 of these guys with the $150 I have. All right, but we know that's not usually the way that things work. Typically, prices go up over time. So let's say that the bananas have an inflation rate that hits them of 20%. All right, so bananas are going up in 20% in cost. So now a banana costs $1.20. All right, so now what is my purchasing power? Well, this is pretty easy to figure out because you have $150 and a banana costs $1.20. So the question is just basically how many bananas can you buy? So we can just do some quick division here. So 150 divided by 1.2. I could buy 125 bananas. All right, that's my purchasing power now of my $150. You'll see that that's different than if we had just taken the 50% and then subtracted 20%. That would have told us that we had a 30% increased rate in our purchasing power. But if you see here, we went from being able to buy 100 bananas to being able to buy 125 bananas. That's really only a 25% real inflation adjusted return. All right, whereas up here we said it would be 30% if we did our incorrect math, from before. So we know that that's definitely wrong. So that's a way that you can kind of prove that calculation is incorrect. So let's get away from bananas for a minute and talk about how this applies, just in general to our purchasing power. So instead of bananas, just think about the general cost of goods going up over a certain amount of time. So let's think about our previous example where we had a 10% return, but we also had 3% inflation. Okay, and we'll just say this is like general inflation, over just goods in general. So what you can think about is if you started with $1, now you're going to have $1.10 from the return, but that $1.10 won't purchase $1.10 $1.10's worth of materials from the previous year. So let's say this has been over 1 year. Okay. So if there had been zero inflation over this 1 year, your dollar would turn into $1.10, and you would have $1.10 worth of purchasing power, 10% more purchasing power. However, since there's 3% inflation, that means that the dollar itself, from inflation, $1.03 this year is the equivalent of what a dollar would have bought last year. Okay. So last year's dollar now is really the equivalent of $1.03. That's how much you need to purchase what used to cost $1 last year. So you can just kind of think about it like this. I've got $1.10, but the dollar itself is really worth $1.03 from the year before. So you can just divide it and see how many dollars that's worth today. So if you do this calculation, okay, you'll see that you have $1.10 is really only going to be worth $1. So like $1.06796, approximately. So it's actually worth slightly less than 7%. You would get 7% if you just did the 10 minus the 3. But in this case, it's actually worth slightly less than $1.07. So in this case, you could see that your inflation adjusted return is really not 7%, but 6.796%. Okay. And that's because your dollar grew to $1.10, but it really only has the purchasing power of $1.06796. And you might say, well, big deal, it's pretty close. But again, just like with a lot of this compound stuff, if you compound over a long period of time, small differences end up making a big difference over time. All right, so what's a general formula then that we can use to figure out the value of an investment taking inflation into account? So what you can do is you can say our final value is going to be our initial value, whatever we start with, times 1 plus the rate of return. That's going to be in our numerator, from over here, that $1.10, over 1 plus the rate of inflation. So this guy right here is our actual, it's going to be our actual, what we call the growth factor. All right, the growth factor is what you multiply the principal by to figure out your final value. Normally the growth factor would just be 1 plus the rate, but in this case we have to divide by the 1 plus inflation to adjust for the purchasing power of the dollar or your monetary instrument of choice. Now we can do this over time as well, so we can compound each of these to a certain number of years by raising them to the t power. And actually we can simplify this a little bit, because if you remember your exponent rules, they say that if you have a quotient to a power, then you can really do the quotient first and then just take everything to a power. All right, so a quick example would be, say you have $100,000 and we're going to have a growth rate. Say that we have a growth rate of 8%. Let's make it maybe 12% just for fun. And you're going to factor inflation into it. So we're going to say that inflation is maybe 2.5%. Put in whatever you feel is appropriate. And we're going to let it sit for 10 years. All right, so how much will the $100,000 be worth in the future in inflation adjusted value? So not just the value, but in inflation adjusted. We can actually do both calculations. So we'll do it with like no inflation, and then we can do it with 2.5% inflation. Okay. And let's see what the difference is going to be. I'm going to rewrite this. All right, so if we had no inflation, then we would just take our $100,000 and multiply it by 1.12 raised to the 10th power. All right, so with zero inflation, this is going to be the nominal amount that we actually are going to have. You know, this is what will actually be in the bank account. It should be worth about $310,000. Right? All right, so that's the nominal amount. That's how much we'll actually have. But if we take the inflation into account to figure out how much purchasing power we'll have, of like what the equivalent would be in today's dollars, then we have to do the 1.12 divided by 1.025 raised to the 10th power. And obviously this will be smaller. You'll see we'll have the equivalent of $242,628 and about 37 cents. All right, so compare these. This is the amount that we'll actually have in the bank account. This is basically the amount in today's dollars, because everything we're doing with the inflation is based on today's dollars. So you'd have about $250,000 of today's purchasing power. And this is a fairly easy calculation to throw into, you know, Excel spreadsheet. Really, it's almost exactly the same as the compound growth formula, but you just have to add in, you know, this extra part down here with the 1 plus I. That's really all there is to it. Now, if you want to actually figure out the actual inflation rate, or sorry, the actual rate of return, inflation adjusted, so you want to know what the actual percentage is, then it's a really similar formula. We basically just need to get rid of the principal part. We're going to have the 1 plus the return to the over the 1 plus I all to the t power. So that'll be like that'll be the value that we get, and then we need to subtract 1 if we want to actually get like the rate of return. All right, so for example, over here, if we take the same values like the you know, the 1.12 and then the 1.025, raise that to the, how many years? 10 years. And if we subtract 1, so I'm just going to take this off of there, subtract 1, it actually tells me that my rate of return is about 142.62%. Okay. And actually this makes sense, because check it out down here. We started with $100,000 and that turned to 242,628. All right, so that's 142% return. All right, the 100% return adds another $100,000. That gets you up to $200,000, and then the extra 42% adds the 42,000. All right, so you can see it right there in the number. So that tells you the actual rate of return. If you wanted to, you could figure out that rate of return and then just use that in your calculations, and it would already have the inflation adjustment baked into it. Now, if you're curious why I have to do the subtract 1, it's because if you went back to this calculation here, we had the 10% growth rate and we had the 3% inflation, and that gave us a 1.06796. That's because this is what's called the growth factor in mathematics. Growth factor is the thing that you multiply your numbers by to get to the next value, to get to your future value. But the growth rate is just this part here. Okay, that's the rate. So if you want to get just the rate of growth, you have to subtract that 1 off and make this 1 go away, and that'll give you the growth rate. And that's where this, you know, this 6.796% came from. So it's kind of a subtle difference between these two formulas. This guy over here is just specifically giving you the rate of increase that's inflation adjusted. And if you don't want to do that, if you just want to see what your dollars are going to be worth, then you would use this formula here to see what your purchasing power is going to be of a certain amount of money that you started with. So it's kind of two different calculations, and they both can be really useful, and it's good to be able to use both of them.